세 번째 세션에서는 D-Wave의 정성근 님께서 Quantum Advantage for Logistic Optimization, Quantum Solution for Operation of the Busan Port Terminal 이라는 주제로 발표해 주시겠습니다. May I have your attention, please? We will now begin the third session of the Quantum Industry session. In this session, Mr. Seon-Geun Jeong from D-Wave will give a presentation on the topic Quantum Advantage for Logistic Optimization, Quantum Solution for Operation of the Busan Port Terminal. Please welcome. 큰 박수 부탁드립니다.
Hello, I'm Seon-Geun Jeong, and I'm a PhD program student at Busan National University. In this quantum industry session, I would like to introduce our quantum advantage project because I think the quantum industry session is to introduce the quantum computing can be used in industrial, and so I think our quantum advantage project is suitable. The topic is quantum advantage for logistic optimization at the Busan port. In this project, our consortium consists of Busan National University, KAIST, Komeri, Busan Port Terminal, and Busan Metropolitan City. First of all, I would like to the quantum advantage project, so we can know what is the quantum advantage project and what will we do. And after that, I will show you the research process and research result and our future work. In the field of logistic optimization, material science, cryptography, drug research, and financial optimization, it is difficult to solve these problems using classical computer. But quantum computing is known as a promising technique to solve this problem. So the Ministry of Science and ICT wanted to verify the potential of the quantum computing in industrial. So from up to now, maybe 6 projects are adopted. Our project is one of the projects in this quantum advantage. Okay, I will introduce our research background and necessity. South Korea is the highest trade dependency globally. With respect to the trade dependency in Group of 20, Korea is third in export and second in import. In addition, 99% of international trade is handled via maritime transport due to Korea's geographical characteristic. And Busan port is the largest maritime trade gateway. In world, Busan port ranks second in transshipment and 7th in total cargo volume. And Busan port handles 75% of South Korea's cargo volume, so Busan port is very important in Korea. However, the Busan port's global port competitiveness decreases every year because in Busan port, they make a plan based on their experience. So they don't use any algorithms. So sometimes it is inefficient and they cannot respond to the unexpected events. And the IMO, International Maritime Organization, mandates carbon emission reduction of ships. So it is important to make a plan optimally. And let's see the right side figure. And there are a lot of terminals in the world. Specifically, in Singapore, the government manages their terminal. So they use the same terminology, and they use the same process, and they use the same data format. But in the case of the Korea, in Korea, private terminal company manages each terminal. So each terminal uses different terminology and different data format, and they have different operating process. In addition, in Korea, the ships usually come from Japan and China. So maybe it takes 3 hours or 6 hours. So it is important to respond quickly. This means lack of standardization, and these issues lead to decline the logistic competitiveness of Busan port. So our quantum advantage project goal is to optimize port logistics using quantum computing technology by achieving quantum advantage and enhancing Busan port's global competitiveness. At the Busan port, the port planning manager establishes this berth allocation 3 days in advance. But frequently, this scheduling should be rescheduled because sometimes the ship can be delayed due to the weather or previous port working delay. And the key crane can be breakdown. For example, the sensor of key crane or operating system of key crane can be breakdown frequently. At that time, we cannot use these berths. So the rescheduling is required, and the key crane worker is human. So working time depends on their experience. So sometimes working delay is occurred, and this timetable is made by humans. So sometimes ship overlapped and unused berths are also occurred. In this case, rescheduling is required, but it is difficult to reschedule quickly due to the high complexity. In addition, the IMO mandates to reduce of greenhouse gas emission of ships. According to the report of Carbon Global Industry Alliance, optimizing the ship speed between previous ports to arrive just in time can reduce greenhouse gas emissions by 10%. Let's see below figures. This is a timetable, and we provide this timetable to the ship company, and the ship company will come Busan port at this time. So the ship will come at the previous port with full speed, but this is not optimal. So they will wait at the port. This is port mooring time. At that time, the greenhouse gas will be occurred. But if we optimize this berth allocation plan, or if we respond quickly to the unexpected event, then they can manage their speed. This is just in time. In this case, the ship company can reduce their greenhouse gas emission. Okay, I will show you our research process. In this page, I can summarize our quantum advantage project. In general, at the port, it is divided into 2 sides. One is key side, and the other is the other side. In the key side, the ship comes and they wait and they dock to the berths. After that, the key cranes are assigned to the vessel, and the key crane load and unload the containers, and the containers can be moved on the storage in yard. Our quantum advantage project focus on this key side. Specifically, in the key side, the terminal company allocate the vessel to the berth. This is berth allocation, and the terminal company assign certain number of key cranes to the vessel. This is key crane allocation. After that, the containers load and unload order is determined. This is a key crane scheduling. But after that, the yard operation and gate operation are conducted. In our project, we focus on these problems. In the case of the first allocation problem, let's see this figure. The sky blue rectangular is ship. The y-axis is length of ship, and the x-axis is processing time for loading and unloading containers. And this orange is the first section, and this x-axis is time. So we assign the ship to the first while considering the time. This is the result. And after that, we assign the key cranes to the vessel while considering the moving range of key cranes to satisfy the processing time. To solve this problem, we proposed quantum computing framework. First of all, we received the Busan port terminal port data, and we formulate the berth allocation problem and key crane allocation problem. Actually, this problem can be solved using classical computer, but to solve this problem using quantum computer, we should convert this problem into the QALO model. So after formulation of QALO model, we apply pre-processing to reduce the searching space, the cost, and after that, we apply D-Wave CQM solver, and we can obtain the solution, and we apply the post-processing algorithm. It can improve the solution, and it can make this timetable. From this timetable, the port planning manager refer our result to make their berth planning. In our quantum advantage project, there is an important issue. It is securing D-Wave quantum computing resources. To secure the D-Wave quantum computing resources, we visited D-Wave headquarters and we presented our quantum advantage. And after that, we frequently had a Zoom meeting, and after that, D-Wave visited the Busan port terminal, and after that, finally, we successfully signed to the contract to use D-Wave quantum computing resources. And we studied with D-Wave collaboratively, and we obtained good results, so we can present at this time, and also we will present Qubit 2025 conference. And this is one of the another issue. Our major is not port logistics, so we should learn the port logistics, and quantum advantage project consider real problem size. So we received real port data from BPT, and we learned the real port logistic process in BPT. So we defined the berth allocation problem and key crane allocation problem based on BPT. And we also visited the test bed, and from this our defined berth allocation problem and key crane allocation problem, and we studied. Okay, I will show you our research result. First of all, I will show you the IBM quantum computing based berth allocation. In this case, we applied the QALO algorithm. This is Covilla optimizer based result. This is just iteration. Finally, our result is that QALO can solve a berth allocation problem for 3 ships, but in real problem size, the port planning manager consider weekly plan. In weekly plan, they consider 50 ships, so it is not enough. So we used the D-Wave quantum computing based burst allocation. In this burst allocation, we used our proposed hybrid quantum computing, and we obtained these burst allocation problem with 3 shifts, and we adopted benchmarks as such as branch and bound, genetic algorithm. Genetic algorithm and branch and bound are widely used in this field, and CQM solver is D-Wave solver, and our algorithm also include D-Wave solvers. And CQM solver and our algorithm can solve this problem within 30 minutes. Specifically, the burst allocation problem and key-crane allocation problem should be solved within 1 hour. This is required real time in the real field. But the genetic algorithm and branch and bound algorithm cannot satisfy this real time. In the case of the key-crane allocation problem, we also used this algorithm, and our algorithm can obtain the suboptimal within 2% error. In terms of the computation time, the D-Wave CQM solver and our algorithm can satisfy the required real time. So from these results, we verify the potential of D-Wave quantum computing based logistic optimization. Okay, I will show you our future plan. Actually, our quantum advantage project began from last year. So the phase 1 is completed. In the phase 1, our goal was, in the case of the burst allocation problem, we wanted to solve the 23 shifts, 5 vertices within 1 hour. In the case of the key-crane allocation problem, our goal was to solve 15 key-cranes, 5 shifts within 12 hours. But we obtained these results in the case of the burst allocation problem. Our result is 30 shifts within 1 hour. In the case of the key-crane allocation problem, we solved 15 key-cranes and 29 shifts within 1 hour. So in phase 1, we verified the potential of the D-Wave quantum computing based solution, and from this year we begin phase 2. In this phase 2, we will improve the problems. We increased our problem size to real problem size. In real problem size is 50 shifts, 15 key cranes, and 5 verses. So we should solve the problem from 30 shifts to 50 shifts. And I aforementioned before, the rescheduling is required frequently. So in that case, the rolling horizon algorithm is required. So we will implement the rolling horizon algorithm from this year. Specifically, the rolling horizon algorithm considers just a certain time window. So, for example, for 3 days, the scheduling is conducted again and again and again. But in the case of the phase 1, we just consider weekly plan. And in the case of the standardization, the BPT and Busan Port Authority and COMERI consider this one. BPA announced the chain portal. In the case of the chain portal, we can share the logistic company, ships company, terminal company, driver companies information can be shared simultaneously in real time. From this platform, we can receive the port data, and we can use this quantum computing framework. And this standardization is important because in this quantum advantage project, we consider only the BPT, but when we consider another terminal, at that time the data format or the operating process should be standardized. And when we consider the outside, then this, if another port and another terminal use our standardization, then they can use our quantum computing framework. Okay, thank you. Is there any question?
Thanks for the talk. Do you have any plans or any thoughts about, I'm sure there are similar problems in other ports. Do you have any thoughts about doing similar work at other ports, or have you considered, looking at data from other ports?
Actually, in case of the Busan port, there are several terminals. For example, Busan port terminal or Hanjin terminal. In that case, Busan port terminal used the vessel name like based on IMO standardization, but another company use another vessel name, even it is same vessel. So in that case, the data format should be standardized, and after that, our quantum computing framework, we formulated the optimization problem. In that case, we require certain variables, and in that case, if we consider expand or other things, they should share our required variables. All of these things should be standardized. After that, we can apply anywhere.
Okay, I see. So standardization of the input data is one of the biggest challenges in terms of putting it, implementing it at other terminals and other ports.
Yes.
Okay, thank you.
I think it would be important to feedback some schedules by using some real data, because there will be some variation of scheduling. So do you have any plan for those kind of feedbacks in real time?
Actually, in BPT, they first determine the Bursal location, and after that, they determine key cranial location problem. In this case, we can support our quantum computing-based ledger to them, but in this case, we cannot include all the real constraints, or in addition, there is a relation between terminal companies and ship company. Sometimes this ship should be assigned in this section in this time, but we cannot include in our algorithm. But based on our ledger, that they can refer the assigned ships. At the time, maybe the port planning manager refer our system, but in real system, they requires the ledger should be obtained within 1 hour. So within 1 hour, if we support the quantum computing based ledger to them, maybe they can use our ledger to make their plan.
Thank you very much.
We truly appreciate your time and expertise. Thank you very much.